Hello and welcome to this pre-recorded event for International GCSE and the Edexcel Certificate in Chemistry. Feedback on June 2015 question papers. To help you get the most out of this feedback, you may want to have the following documents handy, as we will refer to them during the event. Specification, question paper for 1C, mark scheme for 1C. The Principal Examiner report is not needed during the event, but it will be useful to refer to it shortly after the event. The reason for choosing 1C is that this paper is common to both chemistry as a separate science and to part of the double award course, and also contains the assessment statements that are tested most frequently, on paper 1 for all candidates. Many are also tested in paper 2 as well. Paper and pen or pencil will be needed for the activities. The purpose of this event is to look at some actual answers seen in this summer's Paper 1C and to consider reasons and possible explanations for not scoring full marks. These issues are referred to in the Principal Examiner's report, and some of them are seen in most examination sessions. The limited time we have available means that we won't be looking at whole questions. This is because there are many question parts that are very well answered and from which we can't learn much by looking at completely correct answers. Instead, we will focus on certain question parts that students have found problematic, starting with 4E. For all of these, and others later in the presentation, it will be good to have access to the complete question and the mark scheme to see the context. Note that in question parts worth 2 or more marks, it is usual to identify the marking points by using M1, M2, etc. This is an example of a good answer to question 4E. Notice that the answer clearly refers to the residue, correct, and uses the correct terminology, wash with deionized water. The reference to removing impurities could have been slightly better if soluble had been included. But this answer is easily good enough to score M1. The lack of punctuation before the reference to leaving the residue to dry is not a problem, and M2 clearly scores for this. This answer shows a common mistake. Even though the question asks how to obtain a pure substance from the residue, this candidate describes what should be done to the solution. In situations like this, it is not possible to award any marks. The message here is, understand the difference between a residue and a filtrate. Although question 4E does not refer to the preparation of insoluble salts, it tests the same skills that students should have acquired while doing such a preparation. Students who carry out simple experiments like the one in 4.8 are likely to be better at answering questions of this type. If this is not possible, then the next best alternative would be to watch a teacher demonstrating and commenting on such an experiment. Failing that, then watching a relevant video clip would be sensible. Very much less satisfactory would be to read a description in a textbook. Activity 1. Use the mark scheme to suggest an appropriate mark for this answer. That's what the paper and pen is for. Pause the recording while you decide. Then I'll justify the examiner's mark. No reference to any method of drying. Reference to crystallize suggests that the solution is being written about. No marks. 5F Part 1 is in the last part of a 15-mark question about various organic compounds. It tests the calculation of an empirical formula. Many students are well practiced in this type of calculation, but others make serious errors that often lead to no marks being awarded. In this type of question, students should write their final answers on the response lines. If they do that and their answers are correct, then full marks would normally be awarded, as in this example. Ideally, students should include a few words to indicate what they are doing, but here, without any words, it is still clear what working they are using. This answer scores no marks. The student has used the percentages directly as numbers in the formula, then bizarrely multiplied the values for C and F by the relevant atomic mass, then divided by 6, making a decimal point error as well. Most students do well in these calculations, but a small number don't seem to know what to do. Many of those who make an attempt and score no marks often divide by atomic number instead of by atomic mass. And where elements that are gases at room temperature are involved, then division by 2 for hydrogen, by 32 for oxygen, and other similar errors are often seen. The usual outcome is no marks for division by atomic numbers, but partial marks can be awarded consequentially for the use of molecular masses instead of atomic masses. The obvious way to succeed is plenty of practice, perhaps using the many examples in previous papers. Activity 2. Use the mark scheme to suggest an appropriate mark for this answer. Pause the recording while you decide, then I'll justify the examiner's mark. Although the percentages are divided to obtain a ratio, the wrong value has been used for hydrogen. The atomic mass of helium has been used. Then, no attempt to convert the calculated values into a whole number ratio, and no formula on the answer line. No marks. (6F) Part 2 is the last part of a 17-mark question about hydrocarbons and their combustion. It tests knowledge of environmental problems caused by sulfuric acid. Although most students are familiar with the term acid rain, the mark for giving an acceptable specific effect is less often scored. Only the formula of sulfuric acid has been used in the question, so the first mark scores for recognizing that it contributes to acid rain or that it makes lakes acidic. The second mark scores for a specific harmful effect on the environment, in this case, fish dying. As in the previous example, the first mark scores in the first sentence. The reasons why M2 is not awarded are: erosion of limestone is a physical process, not a chemical one. Causing the living organisms in the water a problem is not specific enough. The specification statement does not give detail of the acceptable problems, although these can be found in a textbook. To avoid students describing effects that do not score marks, the best thing would be to look at recent question papers and mark schemes to see what sort of answers are acceptable. Activity 3. Use the mark scheme to suggest an appropriate mark for this answer. Pause the recording while you decide, then I'll justify the examiner's mark. The term deforestation is considered to be mainly used for humans cutting down trees to use the land for other purposes, so does not score. However, the second sentence contains both marking points, the mention of acid rain and trees dying. The last sentence would not score as the reference to buildings reacting is not generally true. Slates and glass are very little affected. It would score if the reference had been to buildings made of limestone, as this would have indicated some relevant chemical knowledge. 2 marks. (8C) is one part of a 14-mark question about doing a titration and analysing the results. This part tests knowledge of specific and universal indicators. Although most students may be able to recall the actual colours of indicators, this knowledge does not help them to answer this particular question. The actual colours quoted here are not important. They were given in the previous multiple choice question. But the positive statement sudden is what scores the mark here. Even without that, the reference to gradual, which would be assumed to refer to universal indicator, would also have scored the mark. All the words except the last 4 are correct, but not relevant. The last 4 go some way to answering the question, but easier is too vague and does not come close enough to the idea of the change being sudden. There is a separate assessment statement about the use of indicators. 4.9. Describe experiments to carry out acid-alkali titrations. But the 2 on screen mean that candidates should realise that universal indicator has a range of colours, in contrast to the others which have only one colour change. Candidates who have actually carried out a titration will have realised that a colour change has to be sharp, or other equivalent words such as sudden or needing only one drop, and should be better prepared to answer questions of this type. Activity 4. Use the mark scheme to suggest an appropriate mark for this answer. Pause the recording while you decide, then I'll justify the examiner's mark. The words distinct and single would both score the mark, and either word would be acceptable. The reference to pH is incomplete, but that doesn't matter, and neither does writing capital P-H instead of P capital H. The reference to the broad range of universal indicator would also have scored instead, provided there was a reference to colour. 1 mark. (8D) is one part of a 14-mark question about doing a titration and analysing the results. This part tests knowledge of how to read a scale, and students are even told to record all values to the nearest 0.05 cubic centimetres. Although most students do well in questions of this type, there are many recurring errors seen. In many pieces of apparatus, the reading should be taken by reading upwards, which is what should be done with measuring cylinders and thermometers, but not with burettes. More commonly, students ignore the instruction in the question about the precision to use. This slide shows what the candidates see. In the before diagram, the level is exactly on 2.3, so should be recorded as 2.30, while the after level is halfway between 24.1 and 24.2, so should be recorded as 24.15. This answer is exactly what we are looking for. Everything correct and also clear to read. Definitely 3 marks. This example is also clear to read, but contains 2 errors. One is the missing 0 from 2.30, and the other is the writing down of the readings in the wrong boxes. The subtraction in this example should strictly be given a negative sign, but this issue is ignored and the subtraction awarded a mark. 1 mark. Recording burette readings is considered to be part of describing how to do a titration. As with other practical aspects of chemistry, students who have actually carried out titrations will have practiced recording such readings. Those who read burette scales in the wrong direction, writing down 3.70 and 25.85, may not have used a burette before. Giving students hands-on experience with burettes should help to prevent such errors. Those who write 2.3 instead of 2.30, in spite of the instruction in the question, may not understand the instruction or how to apply it. Answering similar questions from previous papers should help to prevent this happening so often. Activity 5. Use the mark scheme to suggest an appropriate mark for this answer. Pause the recording while you decide, then I'll justify the examiner's mark. This one is easy to decide about. The only error is the omission of the trailing zero in the before value. 2 marks. (9b) Part 1 is one part of a 17-mark question about the structures and properties of different substances. This part tests candidates' understanding of how atoms form ions. In spite of the information provided at the start of Part B, it is disappointing to see references to sharing electrons in some answers. The first 2 lines score M1 for the ideas of electron transfer and the correct direction of transfer. They also score M2 for the statement about a magnesium atom losing 2 electrons. The 4th line clarifies that the 2 electrons from magnesium are gained one each by 2 chlorine atoms, so M3 is awarded. This answer seems to show some understanding of loss and gain of electrons. Find seems equivalent to gain. But there is no clear statement of the direction of transfer. The wording of the last 2 lines is vague, and the phrase, joined together, applied to the elements and to their electrons suggests covalent rather than ionic bonding. No marks. Students are given the dot and cross diagrams for magnesium and chlorine atoms and are asked to describe the electron transfer involving a group 2 metal and a group 7 non-metal. The most common error in answering questions about bonding is to confuse the different types. Here, any suggestion of sharing atoms means no marks, but other errors include using the terms atom and ion and chlorine and chloride wrongly. So, it is not correct to state that chloride ions gain electrons. Activity 6. Use the mark scheme to suggest an appropriate mark for this answer. Pause the recording while you decide, then I'll justify the examiner's mark. Lines 3 and 4 use the words gain and gives to clearly indicate the direction of electron transfer, so M1 is awarded. The idea of magnesium losing 2 electrons is missing, so no M2. Although chloride is wrongly used instead of chlorine in line 5, the reference to atom is correct, so M3 is awarded for the reference to gaining an electron in lines 3 to 5. 2 marks. (10C) is one part of a 12-mark question about investigating the rate of decomposition of hydrogen peroxide solutions. In Part B, different solids are tested to see how effective they are as catalysts in a decomposition. Part C asks students what to do with the contents of the flask in order to show that one of the solids had acted as a catalyst and not a reactant. Clearly, an answer describing a practical procedure is expected. It was disappointing to read so many answers that just stated what a catalyst was. Even though the obvious method, filtration, is not mentioned, this answer scores M1 for the idea of removing the solid and weighing it, ideally drying it before weighing it, although this was not essential. Then, the idea that the mass should be unchanged if it had acted as a catalyst clearly scores M2. The reference to weighing the catalyst before using it is not needed, because the question states that 1 gram was used. The reference to filtration and reweighing scores M1, but there is no indication of the outcome, such as no changing mass or still weighing 1 gram. In other words, this student has described what to do, but hasn't got as far as stating the result that would show that the solid actually was a catalyst, which is what the question required, so M2 is not awarded. This assessment statement does not go into detail about what is expected in a description, but this has been clarified in previous question papers. Students are expected to realise that a catalyst increases the rate of a reaction but can be recovered chemically unchanged at the end of the reaction. There is another assessment statement, 4.21, explain that a catalyst speeds up a reaction by providing an alternative pathway with lower activation energy, which some candidates referred to in answers, but this is not relevant to this question. Such answers offer explanations about how catalysts work, but this question asks about describing an experiment. Activity 7. Use the mark scheme to suggest an appropriate mark for this answer. Pause the recording while you decide. Then I'll justify the examiner's mark. The word approximately is ignored, so the idea that the mass is unchanged at 1 gram scores M2. Although there is a statement that the solid should be weighed, there is no reference to its removal or to a method such as filtration, so no M1. 1 mark. (1) The current specification does not list the command words used or their meanings, although this will change in the new specification for first examinations in 2018. In the meantime, students should try to understand the crucial differences, for example between describe and explain, by looking at question papers and mark schemes from previous sessions. 2. The general guideline is 2 answer lines per mark, although this is sometimes varied. 2 marks suggest that 2 separate points need to be made, for example. Complete sentences are not usually needed, and the use of brief answers in bullet points is often a good way to give an answer. 3. The best example of this is in the topic of chemical bonding, in which it is very important to distinguish between covalent and ionic bonding, and to distinguish both of these from intermolecular forces. Candidates who write answers such as "the ions are joined by covalent bonds" are not likely to score marks in questions about bonding. 4. Some words seem to mean the same thing to many candidates, for example, atom, molecule, and ion, but using the wrong term often leads to loss of marks. For example, if the expected answer to a question is reduction occurs when chlorine atoms gain electrons, then an answer that states reduction occurs when chlorine ions gain electrons will not score the mark because the statement is chemically meaningless. 5. The specification requires candidates to be able to write descriptions of experiments. They do not have to carry out experiments individually, although this is often the best way to understand the reasons for practical procedures. In the absence of individual practical work, teachers are advised to use the best possible alternatives. In order, these are teacher demonstration, video clip, computer animation, textbook or worksheet. We constantly look to improve the delivery of our training and appreciate all delegate feedback. You will soon receive an email directing you to our online feedback form. The form takes no more than a couple of minutes to complete. Please take the time to let us know your thoughts by filling in this short form.